Yeah. Let's have a look at number presentation. Okay, I think today I will improve my handwriting. The presentation. Yeah. So as we have realized, we have decimal numbers. We have a decimal number system. So we said the decimal number system, these are counting numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, isn't it? So how many numbers are here? There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are base 10, as we said last time. So when you are writing here, we say that even if we write 100, let us say 112. So for us to make sure that this number is a decimal number or a counting number, we say 112 is 10. Hizi ni vitu mlikuwa mnasomanga high school. And we say that for a computer to understand, a computer usually uses what's called binary number system. These are bits. So every time you are using high level language, like 0, 1, 2, 3, these are high level language that you can understand. So for a computer to understand this language, this computer usually needs to translate. And we talked about a translator and a compiler. And up to now, you should be able to differentiate what's the difference between an interpreter and a compiler. We say the word bits, it's discovered by binary digits. So there's someone somewhere who said that instead of calling to binary digits, he took the by and its, then he called it the bits. And say bits, there are only 0 and 1. Okay, there are only 0 and 1. There are 2, so we call them as base 2 binary numbers. So because there are 0 and 1s, so every time you write high-level language, a computer needs to translate into zeros and ones, isn't it? That's how a computer understands. So when you are, if you want to write a binary number, which is a base 2, you need to put a 2 there, so that you say that this number is a base 2. So we have a decimal number. I discovered about the binary number. We also mentioned about octal number system.
open Excel so that I can show them. Mnaweza weka hapo nifunzie hapo. Ama tumechelewa.
Kwenye next week.
Ngoja tunamaliza hii kitu sasa. Onyesha hiyo Excel. Tenda kwa nafasi kwa nanda kwa calculation. Mimi nataka kuweka vitu vingi. So today we were supposed to start the number system, and the number system is a very key in terms of knowing how a computer works. And normally a computer works in terms of zeros and ones. Just a minute. Then the decimal number system. So we were saying that we have 4 categories of number systems. And let me repeat because I've discovered we muted. There's the decimal number system, which is base 10, binary number systems, which is base 2, octal number system, which is base 8, hexadecimal number system. So the decimal number systems, the number system has 10 digits ranging from 0 to 9. These are the normal numbers that you use. And normally they are the base 10. These are the normal numbers you know. And normally they are base 10. So it's important to know that, for example, if you have 7, 4, 5, 8, you can see there, that number is what we call base 10. And you can have, this is 7,458. So we have the absolute numbers and absolute value, then place value or position value and the base value. So it's important that we just normally do this combination to get the base 10. So then now we have the binary numbers. These are new ones. Now I'll concentrate on these ones and not concentrate on. So after dealing with the decimal number system, at least you have gotten a little versed with the number systems. Now we can proceed to a different number system known as the binary number system. In contrast, the binary number system has only 2 digits, 0 or 1, and the place values are units of 2s, 4s, and 8s, and 16, and so on. So unlike the decimal numbers, where the place value go up in factors of 10, in binary system, the place value increased by factors of 2. Binary numbers are written as x base 2. When you subscript 2, that's what we call now x base 2. So that when you have 0, 1, 0, 1, 1, 2 is equivalent to 5. And we are going to see how we are going to get that. So can we have, now we want to do a simple conversion of number systems. You can either do that or let's use, let me share through Excel so that we can maybe want to convert a number. Let me share. Let me share this Excel. So we want to convert a number into binary. We want to convert a number into binary. So you will draw that line. Then what I need again, you draw such a line here in your book so that I want to show you something. Where is the lower part? So, for example, we want to convert a number like, let's say you want to convert a number like 10 into binary. 10 into binary. So when you want to convert a number like 10 into binary, we want to use a number like 10 into binary. We want to convert 10 into binary. So if you want to convert 10 into binary, we will type here 10. And we type here 2. So 2. Hope you can see. So we have a number here. So 2 into 10. 2 into 10 is how many times? 2 divided by 10 is, or 10 divided by 2. To 10 divided by 2, you write here the answer. 10 divided by 2 will give you what? Will give you 5. 5 there. but rem 0. Because if you divide 2 by 10, it will give you 5, and the remainder is 0. So that's what you do. 2 divided by that is rem 0. Then you go next. 2 into 5. 2 into 5 will be 2 rem 1. So we are dividing 5 divided by 2 will be 2. It will go there 2 times and it will remain 1. So that's why you can see there. So 2 rem 0. Then 2 into 2 will be 1. 1, no, it will be 1 rem 0. And when you divide 1 divided by 2, it will go there 0 times, and the remainder will be rem 1. And 2 into 0, it will just be 0 here. It will be 0, and the remainder will be 0. So rem 0. So if you want to read the answer, here, you read going upwards. You read moving upwards. Sorry, so let me some arrow here. So if you want to read the answer here, shapes, arrow. What is this arrow? Arrow. What is the arrow? Let me get the arrows. So what happens is that now you use what we call the bottom up. Now you want to write the answer. If 10 is base 10, and that is what we call decimal number system. So the number 10, you know it. But if you want now to write the answer for this particular now in base 2, in binary, the answer will be 0, 1. You start from bottom up. Bottom up approach, I think you are very familiar. So you start reading the answer from the top to bottom. No, from the bottom to the top. So you read upwards like this. So the answer for this particular one, 10 is equivalent to 0. You can see I'm starting from the low one, 0, 1, 0, 1, 0, 1, 0, 1, 0. Then you put a base 2. A base 2 here should be subscript. Let me go to subscript. Yeah, subscript. Yeah. Now, unfortunately, in Excel, there's no subscript. So now 5 is equivalent to that. The other 0 it has disappeared, but so 5 is equivalent to 1, 0, 1, 0. These other 0, even if you add like 10 before this one, this particular one ya kwanza, any other 0 here will be insignificant. Not like anything. So 5 is equivalent to 1, 0, 1, 0 in the binary. That's the equivalent of what it is in binary. So let me share another one. So let's go back to the notes. I think that's what I was trying to demonstrate. Am I sharing the right? What? Yeah. I want to share this. I want to share that PDF. Yeah, so now, like for example, I can give you an example here. If you want to divide 67 into binary from decimal, 67 is the normal number base 10. So again, you divide 33 divided by 2 is 16, remainder 1. 16 divided by 2 is 8, remainder 0. So you do all that until ufike hapa mwisho. Then you read the answer upwards. So the answer will be 67 is equivalent to 1, 0, 0, 0, 0, 1. That's the equivalent of binary number, the direct binary number. If you don't get it, we have a video that is also showing you how to do it online. You go to the LMS and look at the video because it's also well explained. If you didn't get what I'm saying. Then there's the octal number system. Now, octal number system runs from 0 to 7. So the octal number system uses 8 digits from 0 to 7 to represent values of a number. The place value of an octal goes up to in factors of 8 from right to left. For example, to represent an octal number of 7245, we do so by placing each value number in its position of value. So for example, I can see here, how can you convert, for example, 69, the number 69 number into decimal? Now what we do, we can go back to where we were so that we can see how you can now convert it. Now this is what we call base 8. So base 8, now we want to show base 8. For example, we want to convert now the number. Now we are through with this. Now we want to do what we want to convert it into an octal number system. Now the octal number system, for example, we want to convert the number 69. So 69 is written here, but now base 10, but now 8, you divide by 8. 8 into 69, we'll go there, 8 times 8 is 64. So it will go there 8 times. So 8 into 69 will go there 8 times. So 64 minus 69 minus 64 brings a remainder of rem. That is rem 4. That is rem 4. Because 8 times 8 is 64. The remainder will be not 4, it will be 5. Sorry, it will be 5 because it's 69. 69 minus 64 is 5. So it is 5, remainder 5. Now 8 into 8 is 1. Rem 0. Then Then 8 into 1, 8 will go there 0 times, and the remainder rem 1, remainder 1. And 8 into 0 will go there 0 times, and the remainder is rem 0. So now the equivalent octal number system of 69, you read again from up to the top, bottom up. When you read bottom up, the answer of octal will be 0, 1, 0, 5. Then you write a subscript down there 8. So this is the equivalent of 69 is 105, 0, 1, 0. Even if you don't have the other zeros, even if there are 100 zeros at the beginning of this, they don't have any significance because actually it's just a 0. Even if you have like 10 of them there, that's why even if you have that, that's now what we call, that's now the answer when we read from bottom up, bottom to down. So that is the answer to that. Now, let's now continue with the notes as we move. I'm hoping this will be the last lecture. I don't want to have any more lectures. That you have time to prepare. After this cut, we meet in January, we do the exam. Now, that's the octal number system. So you will see here that the octal number system here, the answer is 105, the one we have just done, and you can see the answer is there, and it's very easy. Now, what about if you have a number system, like for example, you have octal number system 114 base 8. You can see this base. When you talk about base 8, you can see base 8 here, upper. So 1148. If you have such a number, how can you convert it into a normal number? The normal numbers, what you call the decimal numbers. Now, to convert that, you start from the end. Like this 4, you start from the end. From the end is where you start with 4. So 4, you multiply by 8 power 0. You start from the end. So it will be 4. That's what you can see here. It will be 4 times 1. No, 4 times 8 power 0. So it will be 4 times 8 power 0. And any number, 1,000,000 to the power of 0 is 1. 1,000 to the power of 0 is 1. So 8 power 0, you can see here, 8 power 0 is 1. So it will be 4 times 1. Because 8 power 0 is what? 8 power 0 is 1. Any number that has a power of 0 is 1. Basic mathematics in secondary. So we start from this end. We start from this end. Then we do plus. The next number is 1. Now the next number, you multiply that number by 8 power 1. So the powers increase as you move on your left. So it will be, remember, there's a plus sign here. We have finished that. So 8 power 1 is 8. Times 1, this number 1. So it will be 1 times 8, because 8 power 1 is 8. So 8 times 1 will give you the answer. Plus, next we move to, you will now multiply this 8. 8, it will be 8 power 2 times 1. 8 power 2 times 1, 8 power 2 first is 64. So that's why you can have 64. 64 times 1, 64. So the number now, you add the totals. You add, so that you can get that this number will be 64 plus 8. 64 plus 8 plus 4 will give you 76. So 76 is actually the number in the base 10. Now that's the actual number in the base 10. So that is the number you will have there. And that's very important for you to know. So that is the number, and that's the answer for conversion. Then conversion between octal is very easy. How do you convert octal? Now octal into binary, because binary is base 2. So these are fairly straightforward because it is the cube of 2. So just remember that the binary equivalent for 8 octal symbols. So for example, 8 octal number 0 is equivalent to 000 in octal. 1 is equal to 001. 2 is 010. 3 is 011. 4 is 100. 5 is 101. 6 is 110. And 7 is 111. How do we prove that? You just take 7. If you want to know that what is 7, so this is the equivalent. This 7 is equivalent to 111 in binary. So, and you see that's just the normal 7. So how do we get the 7? You can, for example, what is 7 in binary? I would like to show you what 7 is in binary. 7 is in binary, the number 7. If you want to convert it into binary, it is very easy. So the normal 7, because just like the normal number 7. So when we say that 7 is, we are saying that 7 is, so we put here 7, and we put here 2. 7 into 2 is 2, is 3, rem 1. Rem 1. And 2 into 3 is 1, rem 1. And 2 into 1, it will go there 0 times. It will go there 0 times. And the remainder is 1. Then 2 into 0 will be 0, rem 0. Rem 0. So now, that's when we say that if it is now, the answer will be 0, 1, 1, 1. You read bottom up. So that's why we are saying that the equivalent of 7 is 0, 1, 1, 1. Ile mpango wetu ya bottom up, 0, 1, 1, 1. So you read from bottom up, then you get what I'm really saying. Hope I'm making sense. It's clear there. So 7 is equivalent to 0, 1, 1. The other thing I wanted to show you is that, for example, let me share. So it means that if you know this table, that 1 is 0, 0, 1, 2 is 0, 1, 0, 3 is 0, 1, 1, 4 is 1, 0, 0, and 5 is 1, 0, 1, and 6 is 1, 1, 0, and 7 is this. Then converting it into binary, it will be very easy. Convert 74 into binary. You just split 74 and 8. So if this is base 8, then you just put 7 in a maanisha. 7 is 1, 1, 1. It is 1, 1, 1. And 100 is 4, based on this table. The other way you can also do it, what is this 74 in the normal decimal number? You must find out what 74 is in the normal base. Now, in the normal base, what is 74? So if you want to know what 74 is, then we have to do something here. Let me share this. I wish I was this. Let me use Word. What can you show me base? Let me use Word. Where's this Word? Let me use Word 2016. I think it is so let me share. Okay. Let me share this. So that was 74. This was so 74 base 8. This was base 8. So when we say base 8, sorry, base 8. Now subscript. You have to have a subscript. 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 It's base 8. So it will be equals. Now you want to convert this. You want to convert this into. So it will be. So you start from the lower side. As I said, you start from 4. You multiply by. That's now multiplication sign. We don't have a cross. Okay, we can use x times 8. So you start power 0. 8. So you start from the lower. Now you are converting it to a normal number. So you convert that. So it will be, sorry, it will be the upper number. 8 times 4, 8 power 0 times 4. So you put in these brackets, this will give you some answer. I just wanted to remove that so that by that, so plus. So you start from the other side, plus. Now you take this 7. It will be 7. So you take 7. But now you multiply times. That is times 8 power 1. Now 8 power 1. So you multiply by that. 8 power 1. So let me put this 8 power 1. Now 8 power 1 is like that. So it will be that. Now, so that equals 8 power 0. 4 times 8 power 0 is 4. And 8 power 1 is 8. So 7 times 8 is 7 times 8, 56. So it will be 56 plus 4 times 8 power 0. Anything to the power of 0, a million to the power of 0 is 1. So it will be 4 times 1. It will be 4. So the equivalent will be 56 plus 4, which is 60. This is now 60 power 10. The normal base 10 will be 60 power 10. Now the normal numbers you know. The normal numbers you know. So it will be, that's now the answer. The normal numbers, it will be 60, the number. Now, this number is the one now you're supposed to convert now. That's the long way of doing it. You have a number, you've been told to convert a number 74 base 8 into binary. We can introduce your table very fast. Just so that we can now continue, so that we can finish. A minute insert is table here. I can insert a table here. A table of 3. So I can have a table here of 3. And I can format this so that I can do what I want. That's the quantity. So I can have that. So that now I can say, so I have 60 here. So I have 60. Now I want to convert this 60 into binary. So I use 2 here. So 2 into 60, it will be 30 rem 0. Then 2 into 30 again, it will go there 15 times. rem, sorry, rem 0. Insert more spaces here. Below. Now, next, it will be 2 into 15. 2 into 15 will go there how many times? 7. Rem. Rem 1. Then 2 into 7 will be 3. Will be 3. Rem 1. 2 into 3 will be 1. 1. Rem 1. That below. Then 2 into 1, it will go there 0 times, and it will remain 1. And that is the end. When you get the zeros, that will be the end. That's what marks the end. Now, if you want now to read this answer, this is what you are saying. We read it like this. So you can see, now you read the answer going upwards. So that at the end of the day, the answer is, now it's good to finish here. 2 into 0 will be 0. Once you reach where there's 0, that's the end. That's the end now. You read upwards. So that the answer for this will be 0. That is what was it? It was our initial question was to convert 74 octal, a number octal, 74 base 8 into binary. So we have used what we call the long, no shortcut, the long way of doing it. It will be 1, 1, 1, 1, 0, 0. And I told you that this other 0, that one doesn't count. Even if you have like 10 after that, it won't count. So in short, we are saying here that 74 base 8. 74 base 8. 74 base 8 is equivalent to this base 2. Now, the answer you get when you are doing binary, it's base 2. So when you write it good 2, you can show now that subscript, and that becomes the answer. So that's what we are saying. And that is, I hope, very clear with you. And if it's not clear, in the notes, we have very good videos with explanations. You can really dwell on and get something. I'm trying to okay, now, if you use this table, and if you will have crammed them, but there is an easier way. Now, the other way was the long way. But if you can know that 0, the representation of this, then you can just directly convert by saying 7 is 1111 and 4 is 101, and it will be the equivalent. So it is possible to convert. Again, if now you are given, you can also be given a binary. You can be given a binary number to octal. If you know what 0 to 7 is, then what you do, you start from your left. You arrange them in threes. You arrange them in threes. For example, this number you'll be given to convert to octal, you arrange them in threes. So you count 1, 2, 3, leave them in threes from left to right. 0, 0, 1, 0, 1, 1, 1, 1, 0, then 0, 0, 1. So then now you just check what is 4 is this. What is 0, 0, 1 is 1. This, and that, and that. And this one gives you the equivalent of the octal. You can also do the long cuts. Go and convert this binary number. You can convert a binary number. You can convert a binary number into a digit. How do you do it? Let me tell you, for example, I have a number like if I have a number like, for example, I have a number like 5. And I want to convert it into what? 5 and then convert it into, for example, I have 0, 0. For example, let's say this number. What is the equivalent of this number? So we convert this number to decimal. Forget about the top part. Let me go up, down so that for example, you have this number. You want to convert it into, sorry, let me share it. Let me share what I forgot. I'm not sharing. Not 5. Let me use this number. For example, you want to convert this number into octal the long way. You want to convert it into octal. Octal is base 8. So this number, you will do this. Then you will just do, you will start from the left. It will be 0 times 2 base 0. So you start from left. So I can so you start from there, plus, hope you're seeing it. Then the next will be 0 times 2 power 1. So 2 to the power of 1. And the 2 to the power of 1, 2 to the power of 1. Then in brackets again, plus times. So again, put a bracket here. Times now 2 to the power of 2. 2 to the power of 2. 2 to the power of 2. Now in brackets, plus here, it will be times 2 to the power 3. As you move the other side, the power increases. The power, so power up, plus again times 2 to the power 4. So 2 to the power 4. Plus times 2 to the power 5. So the powers will increase as you move towards the move towards the right, not the left. As you move towards the left, not the right. Sorry. So you can see I'm converting that number. That number was this number is the one which I was converting 111100. What a zero, zero. There's 2. I'm converting this number into decimal. And what I wanted at the end of the day is to achieve. So this will be equals to. This will be equals to. So it's the same as. So 2. So it will be. Now you start now adding. 2 to the power 5 is 32 times 1. So that is 32. I think it's 32. Then 2 to the power 4 is 16. 16 times 1 is then plus 2 to the power 3 is 8. So plus 8. Then plus 2 to the power 4 is 2 to the power 2 is 4. 4 times 1 is 4. Plus then 2 to the power 1 is 2. 2 times 0, 0. Plus, sorry. 0 times 2 to the power 0. 2 to the power 0 is 1. 1 times 0 is 0. Then you have a total. So the number will be, the number is 32 plus 8 is 40. 40 plus 20. The number is 60. That is now base 10. Remember, we have not gotten our answer because our answer was, our aim was to convert 111100 base 2 into octal. So what we have gotten here now is the base 10 equivalent. Now we have not reached the octal. So we have now to convert this 60 into octal. How do we convert 60 into octal? We go back to the top here. 60 into octal. Now it is 60 the number. 60 the number into octal. So if we are doing octal, we remove now what? You remember now we don't use 2. Here we use 8. It's 60 into octal. 60 into octal. Now if you are doing 60 into octal, so 60 into octal, now we are using 8. 8, the rems here now will be different. So I have to delete this. The remainders will be different. So 8 into 64, it goes there. 8 into 64, 8 times 7 is 56. It goes there 7. It goes into 8 goes into 67 times, that is 56. Rem 4. And 8 into 7 will be 0. Rem 4. Rem 4. Rem 0. Sorry. 8 into 7 will be 0. Rem 7. Sorry. And 8 into 0. 8 into 0 will be 0. Rem 0. Once you reach the 0, then that's the end of the calculation. Once you can just see a 0 at the end. Now you read upwards again. You read upwards. As always, as I told you, you read upwards. You read upwards. So that we are saying, so in short, we are saying this number, the one we had, our question was this number into octal This into octal. This into octal will be, now we read upwards. We read the answer upwards. This binary number into octal will be 0, 7, 4, base 8. When we read it from the top, so it's like that. So that is the number. And you remember, so we are saying that you can convert binary. This binary, convert it into decimal, then use now the octal to convert back to. So this is the long way. There's also, so that's what we are saying. I hope I'm clear. So we continue. So you can also do that. So it's the same way again. We are saying that you can see all the other methods that are there, and it's very important for you to see. So we move to now what we call these are the number system. The one that we call, we have done octal extra. So now we want to move to what we call, I think, the conversions, the fractions. We can also do them, but later. I'm not dwell into them right now. Now, can we dwell now into binary addition? How do you do binary addition? And how do you do octal addition? I want to show you how to add. Adding numbers using octal and binary. Adding octal and binary. Let me try something here, and then we see what to do. Where was we using this? Sorry. Yeah, now we are here. So now we want to add binary numbers. Like, for example, we have this. For example, now our question will be this. Now, for example, we want to add these numbers. This plus this. Sorry. Now we want to add these numbers. So we want to add these numbers, this plus this, so we can get an answer. Now, the normal way you normally add, you can add the normal 9 plus 9, you can add. Now, can we add this? So let me make a table here so that we can do some addition. 1, 2, 3, 4, 5, 6. So you can make a table here. 1, 2. Now I can have this number. The first number is 1, 1, 1, 1, then 0, 0. Then we have 1. Now we want to add 1, 1, 1, then 0, then 0. Then we want to add them. So plus. So we are adding. And of course, all addition starts from the right. What is the border thing? Okay, now we are adding these two numbers. So now we start from this. 0 plus 0 is 0 in base 2. No, but before we go to that, there are simple rules that I have not shown you, which you must now know. Before we go dwell into that, I want to show you very simple rules of addition. 1, 0 plus 0 in binary. 0 plus 0. Sorry. So we have, or we can start. Simple 0 plus 0 in base 2 is equals to 0. 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. And 1 plus 1 is equals to 10. 1 plus 1, so this is what you need to know. You need to know this is in base 2. When you are adding this simple base 2, it's important to know that that is the simple base 2. In base 2, though, that's the rules we are using. Those are the rules we are using. I hope that's clear. So now we say 0 plus 0 is just 0. You can see from the table here. 0 plus 0 is 0. So we just put here 0. Another 0 plus 0 is 0. Now, we said 1 plus 1 is 10. So it will be 10. Huh? Oh, sorry, I'm sharing the wrong thing. Sorry. I'm on something else and I'm not sharing. I'm really sorry. Stop. Let's have to start again. Let me share the right thing. I'm not sharing the right thing. Sorry. Let me just begin again. Because I thought I was sharing, but I didn't share. Now we are saying this number 11100 plus 111100 base 2. You want to add these two numbers. Now the basic rules of adding binary numbers is that 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 10. So those are simple basic rules of adding. You are adding numbers. So whenever you add those numbers, that's what will happen. So now that we are adding, we have put in a table form that this plus this. So 0 plus 0 is 0. That's where we are getting. 0 plus 0 is 0. And 1 plus 1 is 10. So you will write here 10, which is you'll write 0 and carry 1. So here is the carry. Let me put here carry. So here you carry. It will be 10. 1 plus 1 is 10. You write 0, carry 1. Carry 1. So you carry 1. So 1 plus 1 is 10. Plus 1 will be 11. So 1 plus 1, so you will do this. 1 plus 1 is 10. You get this. Plus 1 at the top, it becomes 11. So you write here 1 and carry 1, because now there is 11 there. Again, 1 plus 1 is 10. Plus 1 will be 11. So it will be 1 carry 1. And again, 1 plus 1 is 10. Plus 1, 11. So you write 1 carry 1. Can you convert this number? Now, this is the answer. Base 2. This is the answer, base 2. Can you convert this number into normal number so that I can know the answer if it's right? What is this number? In our normal number system, write on your chart what the number is. Kindly write on your chart what this number is. The number highlighted. The number highlighted. Write on your chart the number highlighted. What number is that? Which number is that? Or your chart? What's the number? What's the number? The number, the answer. I'm talking about the answer. E answer E kwa base 10. I want the answer in base 10. 1, 1, 1, 1, 0, 0, 0. These are 4 ones and 0, 0 that. This answer, the one I've highlighted, what's the number? I'm shocked with what people are giving me. Now, converting that into the normal number, if you want to know the normal number, what is it? This number should be 120. How do we find out? Let me copy it here. As I showed you, it will be times 2 power 0. If you remember that. So you convert it very easily. Plus, so this is this. Then again, times 2 power 1. You start from the left to the right to the left. Then times 2 power 2. Right to left. Times 2 power 3. Two power 4. 2 power 4. Two power 4 plus times 2 power 5 plus 2 power 6 we just want to confirm it. So that's what we are doing. So we are converting this. So we are converting this into base 10. So the answer will be equals 2 to the power 6. 32 times 2 is 64. So it is 64 plus 32 plus 16. Yeah, plus 8. So plus 0 plus 0 plus 0. That's okay? Yes? And the answer is 120. So that number is base 10. We have just done the conversion. We are just reconverting. So this is the same as 160 plus 60 is 120. And we have done it practically using base 2. And the rules are very simple. The rules are very simple. Now, we are moving on to now the subtraction, which is always very tricky. Now the subtraction in binary. It's important to know the subtraction in binary. I want to move to the subtraction in binary. Subtraction in binary. For subtraction in binary, yeah. For subtraction in binary, it's very simple. So now we can take now this number. So we want to do subtraction is 1, 1, 1, 1, then 0, 0, 0, 0, 0, minus, minus, 1, 1, 1, 2, 3, 4. 1, 2, 3, 4. How many? 1, 1, 1, 0, 0. So now we want to subtract that. This is the equivalent of 120 minus 60. Now, simple rules in minusing, in subtraction rules. Zero minus 0, globally, a 0 minus a 0 is just a 0. Globally, 1 minus 0 is equal to 1. Then 1 minus 1 is equal to 0. Now here 0 minus 1, they must always be, you borrow. Here we introduce the element of borrowing. Here you borrow. And we are going to see the borrowing, the way you borrow. You borrow 2. How you borrow 2, you don't borrow 1. You borrow 2. So now let's start. 0 minus 0 is 0. That one we agree. Then 0 minus 0 is 0. Now borrowing starts here. How do you borrow now? Borrow. We want to see how to borrow. Now here, it is 0 minus 1. That one cannot happen. So you borrow 2. You borrow from here. You borrow. Can I cancel? So you borrow here. If you borrow this, so if you borrow here, You borrow now, it becomes 0. And here it becomes 2. When you borrow from 1, it becomes 0. But because it's base 2, you are borrowing 2. If it is base 10, you borrow 10. If it is base 10, you borrow 10. But if it is base 2, you borrow 2. So 2 minus 1 will give you 1. Now you come here again. I need to add another one so that the borrowing can be seen very clearly. Insert at the top. Now, we are here now. We are here. We have discovered that here now it's 0. So we have to borrow from the next. Now we borrow from here. So when we borrow this, when we borrow from here, it becomes 0. Now this one, which was 0, now becomes 2. So 2 minus 1, this is again borrowing. This is just the borrowing. So 2 minus 1 is 1. Is 1 here. And now here we have 0 again. We have 0 here. So we have to borrow. So we borrow from this. So when we borrow, this becomes 0. And then here it will become 2. So it will no longer be 0 because you have borrowed 0 plus 2 is that. So it will become 2. 2 minus 1 is 1. Again, we have now to borrow again. Now this one, if we borrow from here. So this becomes 0. And this one, when we borrow, this one becomes 2. So 2 minus 1 is 1. Now 0 minus nothing here. A 0 minus a 0, if there's nothing, it will just be a 0. So the answer is 0, 1, 1, 1, 1, 0, 0, which is equivalent to 60. So this is your answer. This is your answer now. Your equals. This is the answer. This is your answer. And this is equivalent to 60. You can confirm from your subtraction. So that is very easy, and you can confirm that. So that's how you do addition and subtraction in decimal. Let's see. Let's now move to the next thing. So now, how do we do octal addition? Then we move to the last part. So I want to do now what we call octal addition. Octal addition. Octal addition. So we want to do octal addition. 74 base 8. This is a number we've dealt with. What was 74 base 8? You remember, plus 74. Now you have such a number. 74 base 8. 74 base 8. 74 base 8 plus 74 base 8. So we want to know the answer. Delete. So I'll use just this particular one. So we have 74. Sorry. So 74 base 8. So it is 74 plus 74. This is base 8. Now, This number with that the only rule you need to know here that if you add any two numbers, they cannot pass 8. They have to be between 0, 0, and 7. The numbers only range from 0 to 7. So we want to do an addition here of these numbers. So the biggest rule here, that the numbers cannot pass 8. And I'll show you mathematically something. Let me just show you what I mean here. In short, let me show you before something here. For example, in base 10, let us assume this is base 10. Let me just paste here base 10. Undo. Let me show you something. What I mean. This is what your teachers made you robots, but I want to correct this, but you understand the concept. For example, in base 10, now assume this is base 10. I have a number like 69, 64, and 64 in base 10, the normal numbers. Let me make this one to be 9. The normal numbers, this is what your mathematics teacher, you know, they were meant to be robots. So they say in secondary, they just said 9 plus 4. 9 plus 4 is what? 9 plus 4 is 13. Write here 3. You write here 3 and carry 1. And you carry 1. You carry. This is what your teachers taught you. But in the real sense, this is what, because you are robots then, you didn't know what they were saying. What the teachers were saying, at 9 plus 4 is 13. So instead of telling you that 13, then you bring 10, you minus. 13 minus 10, it will give you 3. So you minus. Then you carry the 1 now here. You carry the 1. So the 10 becomes 1. So this is what your robotic teacher didn't tell you that this is what happens. 9 plus 4 is 13. So it's 13 minus 10, which is 3. So 3, you carry now the 1 there. So you subtract 13 minus 10, because it's base 10. But they normally used to tell you just write 9 plus 4 is 3, carry 1. But the real essence is that. So the same as 12 plus this will be 13. So it will be 13. 13 minus 10 will be 3. Carry 1. So the answer here will be 33 in base 10. So now, after giving that example, now we have to do this in base 8. 74 base 8 plus 74 base 8. I told you the maximum number cannot pass 7. So 4 plus 4 in base 8 is 8. So you take 8 here. 8, that's the answer. So you do 8 minus 8. It will be 0. You will carry 1. Are you getting? So it will be 0 here, but you carry 1 here. You carry 1. Now, it will be then the next one is, so you will carry 1 at the top here. After you get 0, you carry 1. That's why you carry. This is what we call carry. So this, it will give you 0, but now it has carried 1. Now, this is 7 plus 7. This is past. That is 15. 15 plus 1. This is 16. So it will be 16. So it will be 7 plus 7 is 14. 14 plus 1 is 15. So it will be 15. So you take 15 minus the base 8. Minus base 8. So the remainder is what? 15 minus 7 is 7. So you will write 7 and carry 1. And carry 1 at the top. So here you will write 7 here. And you have carried 1. So 1 plus nothing is just 1. So that's the equivalent now. So 74 plus 74, it is 170 base 8. 170 base 8. Let me put the base here so that you don't confuse. It is 170 base 8. 170 base 8. That is the answer. So this is the answer. If you don't know the hard way, you will convert this number into decimal, convert this into decimal, do the normal subtraction of the normal number, then reconvert it back, and you'll still come here. So that's how to add. You can still do the long way. You convert this into decimal, you convert 74 into decimal, then you do the normal addition, then you come back to the same place. And what is this number? The equivalent of this number, again, you can convert. We're not going to bother about that. Now, subtraction. 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 Now, let us go to subtraction. Subtraction. So now we go to binary subtraction. Binary subtraction. Binary subtraction. Let me remove this. Now the carry has gone. Delete this text. Now we want to do binary subtraction. We want to do what we call binary subtraction. So we do what we call binary subtraction. For example, not binary, octal subtraction. For example, give me any number. 74 base 8. Base 8. Minus, I'm just giving you a number from my head, minus 66 base 8. This is a better one. So we want to get we want to do this. So we want to do 744 minus base 8 minus 66 base 8. So we just write here. We write here 7. It is 7. We can write here 7. Now what's the problem again? 7 here. Let me change something here. So 7. This is 744. Now this is subtraction. 4. Undo. So 744 minus, so you write from here again, 66. Of course, addition Nanzianga right. The subtraction Nanzianga right. So minus. Now we introduce here the idea of borrowing. Borrow. But now the borrowing here, when you are borrowing, the borrowing here is you borrow 8. Because It is base 8, you borrow 8. Every time you borrow 8. So note that. Because it's base 8, you are borrowing 8. So 4 minus 6 cannot happen. So you have to borrow. So when you borrow here, this one, you borrow here 1. Sorry, you borrow here. So when you borrow here, so when you borrow here, it becomes 3. This becomes 3. And here, this, you take this 4. This will not longer become 4. It will be the 8 you have carried, 8 plus 4, because you have borrowed 8. So 8 plus 4 becomes here 12. You have borrowed 8. It becomes 3 here. Now the 8 plus 4 becomes 12. So it will be 12 minus 6. 12 minus 6 gives you 6. Now that you borrowed from 4 here, it became 3. But now 3 minus 6 cannot occur. So you have to borrow from 7. You borrow from 7. So when you borrow from 7, you borrow from 7, which was 7, it now becomes 6. But now this 6, you borrowed, now here, you borrow that 1, it will be 8. It will be 8 plus the 3 here. This 3 now disappears. This 3, it will be plus 3, which becomes what? 11. So that 11 minus 6 is what? 5. And 6 minus nothing is just 6. That's the answer for you. Now, it's good to know. Let me put arrows for those who are taking photos. This one you have borrowed to here. You have borrowed. So it's good to know where you have borrowed it. This 8, you have borrowed from here. Then you add the 4. It's good to see how it's coming. Then this 4 is this one. Mathematically, I think that diagrammatically it's showing. Is it the arrow C? Or I make it red. You can see that went there. Now you can see those arrows. Those arrows can help you to know now how you move to there. So for those who are taking photos from this, then this 3 is coming here. I think that is clear of how we are borrowing. You borrow. So this is the simple answer for this particular one, and we have finished. Now we go to the next now, very fast. We want to go to what we call now base 16, which we call the hexadecimal. The hexadecimal, let me now open the notes again. We move to the hexadecimal. Share. Let me share now. Share. So now we move to something called the hexadecimal. So you can see the binary addition, the carries you can see. Now we got something called binary. And the beauty is that these notes can be found. Watch all the videos in the last section. Next week and the other week, just be on the videos watching and winding up as you prepare for your main exam. Then we are having a cut in the evening, so you also be ready. Cut. Na usipofanya cut, usipige kunitafuta. Nikupati. Kierere. Waache kufanya cut, alafu ndio kufanya cut. Nilikupati. Ask your predecessors, they know what the consequences are if you miss my cuts. So don't try. Play monkey games at your home, not here. So we have the hexadecimal. Now, this one is base 16. It runs from 0 to 16 to 15. So you can see base 10, the equivalent is 0 to 15. There's only one difference in hexadecimal, that when you reach the number 10, 10 becomes A, 11 becomes B. You can look at this. I think you can see it very clearly. 11 becomes B, C becomes 12, D becomes 13, E becomes 14, and F becomes 15. So it can never reach 16. This one can never reach 16. But when it reaches 10 is equivalent to A in base 16. 11 is equivalent to B. 12 is equivalent to C. 13 is equivalent to D. And 14 is equivalent to E. And 15 is equivalent to F. Put it in your medulla oblongata and know that that's how it works. So know that that is what works. So we can do a simple conversion like 91 into hexadecimal. Convert 91 into hexadecimal. 91 is 10. So let's go back to our table here. So we want to convert 91. I'll look for what is appropriate. I think this one will help us. So we want to do 91. 91. Huh? Share the other one. So we want to share. Now we want to do 91 practically here. We have a number 91. So the question will be convert 91 base 10 91 into hexadecimal. Hexadecimal. So here the conversion now changes. So we want to do the conversion here. So here you write again. You start with, it's 91 here. 91 is written here. Then here you write 16. So 16 into 91. 16 into 91. So 16 goes into 19 5 times. So it is 5. That is 80. And now remember 80. What's the remainder? It's 11. But we said that, let me insert here another. Yeah. You remember we said 11 is A. No, 10 is A. 10 is A. This is A. We said in binary, 11 is B. 12 is C. 13 is D. You need to remember this. Here, 14 is E, and 15 is F. And there's nothing like 16. So now, using this knowledge, if 16 goes here 5 times, it's equal to 80. So 91 minus 80 will give you 11. 11. So 11, you don't write 11, you write here B. You don't write here 11. It is RAM 11, but it's B. Then 16 into this is 0. And this is RAM. 16 into 0, 16 into 5, it will be go there 0 times. And the remainder is RAM 5. And 16 into 0, once you get this 0, that's the end. It will be 0, RAM, 0. So that's how simple it is. So the answer here, 91 base 10. 91 base 10. 91 base 10 is equals to, now you read upwards, it is 0, 5, B, base 16. That's the answer now. This is the answer. Base 16. So that's the answer. Base 16. That is base 16. Now, how can we convert this now to confirm if it's 91? Can you convert? Convert 0, 5, B, base 16 into decimal. It's very simple. This is base 16. Oh no, it comes here. No. What is happening? Why do you get your equal? Sorry, the whole thing is on. The whole thing in me. So convert that. So convert this. So into decimal. This is very simple. Again, start from the last end. Start from the last end. It will be B times B times. Now you bring in 16, but now power 0. The other ones you start again from the right. 16 power 0. 16 power 0 times B plus 5 times 16 power 1 power 1 power 1 then plus, now there is the 0 there, which we have said even if there are how many zeros, so it will be 0 times 16 power 2, then in brackets 16 power 2 in brackets. So this will be so we are doing this. So again, now I want to link. Now what you need to know is that what is B? This B, I want to link it to where it's supposed to be. This B, the B, this B is equivalent to 11. You need to note. B is equivalent to 11. So instead of using B, you will replace it with 11. So let me copy this, and then I replace the next step so that people don't get confused. So this B so this B here, this B. In the next one, in the next one, and now I replace it with 11. Is 11. Yeah. Good to see how it comes. So I'm gonna share that. Comment. Hope it's clear here. Replace B with Magdesi. So you replace Replace B with 11 for mathematics. So you replace. So the answer here now it will be equals to, just a minute. Hello? Adi? Nani naongea? Mike? Ugari wapi? So 16 to the power 0 is 16. So it will be 11. 11 plus 80 is 91. The answer is 91. And that's how this is base 10. We have gone back to where we were. We have gone back to where we are. So you can see that that's how it comes. So that is what we've done. Now, the other thing is, how do we add numbers? How do we add numbers in? For those who are taking photos, I think that is very clear. So how do we add numbers in base hexadecimal? How do we add numbers into hexadecimal? We can still add numbers in hexadecimal. So like, for example, what we have added there, I want to go and add numbers in hexadecimal. I want to add numbers in hexadecimal. So I'll work with this table again. We want to add numbers in hexadecimal. And we're just going to use the numbers we have already. We are not going to waste time getting new numbers. We're just going to use 05B plus 05B. We want to see. So we want to add these numbers. So we want to add 05B base 16 plus 05B slash 16. Calculate. So you can get such a thing in the exam. Calculate. The hard way will be to convert this number into decimal. Then from decimal, you convert it into, then you just do the normal addition, then you return them back. So this is what we want to do. And I'm using the table above so that you can remember. When it's 10, it's A. Now this is base 16. Base 16 means, when you see base 16 means it's hexadecimal. So we have said 0, 0, 5, B. So is capital, and 0, 5, B. This is equivalent to 91 plus 91. This is the plus side. A plus. So that now we are adding numbers. And I reminded you that you will check at the top. What is B? B plus B. B is 11. So it means it will be 11 plus 11, which gives you 22. So it will be B plus B, which is 11 plus 11, which is 22. Minus 16, 22 minus 16 is 22 minus 16, that is 6. It is 6. So you will write 6 and the carry. There's something called a carry here. So I want to get, you will write 6. You will write 6 and carry 1. So you'll write 6 here. You'll write 6 here and carry 1. So this is 22 minus 16, it will be 6. But we will carry 1, you will not carry 16. So that's how we arrived there. So I think that's how we have arrived there. Then 5 plus 5 is 10. 10 plus 1 is 11. What is 11? 11 is B. At the top there you can see 11 is B. At the top there 11 is B. So you write here B. And here it is 0 plus 0 is 0. And that one gives you now the. How did we get here? How we got here? How we got here? We did this to get here. It's good to know. For those who are taking photos, it will be good to know. This is how we got here. Just winding up class now. Winding up class, I'm calling you. Next. So, under this carry is the equivalent of 1. This 16 now becomes 1. You need to know that. I'm just showing you what happened. So that's what happens, and that's now the addition of, this is how you add. You add in base 16. So the answer is 91 plus 91 is equivalent to this answer. This one. So the answer here will be this is the answer. So the answer for here will be this, base 16. So you know that. Now we go to what? Now subtraction. Subtraction. So that means that another table here. You go to binary. Now binary subtraction. So now, no, not binary. It's a hexadecimal subtraction. Hexadecimal subtraction. And I can have a number like F000 minus let me reduce them. Minus A, B, C. Base 16. So we want to do this. We want to do this base 16. We want to do, so it is F 0 0 0 minus A, B, C. Mean. Now you have that. I want to do subtraction. We had so that we do insert. I want to insert more rows above, because we will be borrowing. So here we will be borrow. We borrow. Hapa kutakuwa na kuborrow. So here we will be borrowing. And our borrowing might be in many steps because many things will be changed. Above. So now we will be borrowing and you will see the effect. Now 0 minus C cannot happen. 0 minus B cannot happen because you have to borrow. And you can't borrow from 0. You can't borrow from this A. So you start borrowing from F. So when you borrow here, when you borrow F, and it's good to remember our table. Good, we bring our table here. It's good I bring this table here so that you can always remember. It's good to remember this table. It's good I have this here. So that when I'm doing it, at the top here, always remember this. So when I'm borrowing here, F is equivalent to 15. At the top, you can see it's 15. So when I borrow 1 here, it becomes F, it becomes E. It's becoming E. It has changed from 16, no, to 14. So if you borrow from 15.1, it becomes 14. So that's why you have E here. Now when I borrow here, I've borrowed here. So when it comes here now, it is 16. Here now it is 16. I've borrowed 16 now. I've borrowed 16. But now I have to borrow the next. So if I borrow from this 16, this will become 15. This will become F. When I borrow this one becomes F. So this one now becomes 16 here. So when I borrow from this, it becomes F. And this one now no longer becomes 0. And now when I come here, this one now becomes 16. So that now this one does not become. I've borrowed from all these other sides for example. So it will be 16 minus C. 16 minus C. C is 12. So it will be 16 minus C, which is 4. Here it will be 4. Then F minus B. F minus B, 15 minus 11 becomes 4. And F minus A is again another 15 minus 10 becomes 5. And then this E minus nothing is E. So that's how, now that's the answer. And that is now what we call hexadecimal subtraction. So that is what we call subtraction. As a matter of the next 2 weeks, you will look at binary multiplication as an assignment and look at the notes and the examples in the slides and be able to do binary multiplication and division based on the notes. Having said that, I think for the last time, Christmas, sorry, I had muted. So the next few weeks, so thank you very much as a class. I'm happy that we have had our session. This was our final session as we prepare for Christmas. And this is what I can tell you. For those who don't know me, I think you can see me here well. Maybe some of you push me in the corridors as we pass each other, but I've been your lecturer for the last few weeks. Thank you for having attended most of the lectures. I hope you have done all your cuts, cut 1. Today in the evening, we are going to have our cut 2. If you miss your cut 1 or you miss your cut 2, you will not get your full results, and that will be your choice. Because if you miss cut 1, and you do cut 2, then you will not have your cut marks at the end of the semester, and it will affect your performance. The other thing is that make sure you do all your cuts, because if you miss any, don't look for me kindly, because you are here to learn, you are here to do the cuts online. This evening we are having a cut from 6. So they are going to open this early. So make sure in the evening from 4, you access your machine using your phone and be able to do, if you need a calculation, because maybe some few calculations will be there, binary, you also have to do. So we are going to have a cut today, starting from 4. So make sure that you are available for the cut. And after this cut, the rest of the notes you are going to read up to week 12, because now I've covered partly everything. So you revise, do all the do all the assignments in every week, and also do the CAT today. And we are calling it a semester. We are now can actually mark that fundamentals of computing semester 1. We are through. We are only remaining with a CAT, which is going to be today. And the next week, you will revise on your own. You will read online. Attendance will be based on how you have been doing the attendance will be based on how you have been doing your assignments weekly. If you have not been doing, then you have not been attending. So attendance will be pegged on the weekly assignments. If you have not been attending, you have not been doing the assignments, it's deemed you have not been attending anything. So make sure that you do the assignments online every week as scheduled. We are not going to entertain jokes. We are not going to entertain the idea of you looking for me that you have not done your CAT 1 or CAT 2. That one, you can ask your predecessors who are now in second year that we are not going to bring jokes. Unless you have a very valid reason, and it must be through the dean of students declaring that you are sick and with the right documentation to the dean of students. I think you are well briefed on the requirements when you miss a CAT. So don't come to me asking me how I'll give you a CAT and you don't know the requirements and the procedure. So follow the university procedure. As being ISO certified, you must follow the procedure. When you miss a CAT, start with the dean of students. Don't come to my office looking for me, and I warn you again, do your CATs. If you miss, follow the procedure. I should not meet you on the street